Hello everyone. In this video, we will take an example of a horizontally shot projectile. In this example, we are given that a rescue plane flies at a speed of 190 km per hour and at a constant height h equal to 490 meters directly over a point where a rescue capsule is to land. We are required to find the angle of pilot line of sight to the point where the rescue capsule is to land. So we are given the magnitude of velocity of the plane, and we are given that it is flying at a constant height. So we know that the plane is flying horizontally and it is flying at a height of h equal to 490 meters directly over a point where the rescue capsule is to land. So this is a rescue plane flying horizontally at a velocity v0 equal to 198 km per hour and at a height of h equal to 490 meters. So h is given as 490 meters and v0 is given as 190 km per hour in the horizontal direction. When the rescue plane releases the rescue capsule, it is at a horizontal distance x from the point where it is to land. So the rescue capsule initially is at a horizontal distance x from the point from where it is to land. At this point, the pilot line of sight is this one. So this is the pilot line of sight, and this is making an angle of phi with the vertical direction. So this angle phi we are required to find in this example. Once released, the rescue capsule will have the velocity equal to the velocity of the plane. That is, it will have a velocity equal to 190 km per hour in the horizontal direction, and it will act as a projectile and follow this curved path. So the rescue capsule will follow this curved path and land at the desired point. From this figure, we can see that h and x are making an angle of 90 degrees. Therefore, tan of phi is equal to x by h. So to determine phi, we need to know the values of x and we need to know value of h. Value of h we already know. Value of x can be obtained by solving horizontal equation of motion. But before solving horizontal equation of motion, we need to know the time taken by the rescue capsule to land, and that time taken can be obtained by solving vertical equation of motion. So in the first step, we will find the time required by the rescue capsule to land from the vertical equation of motion, and then we will find the value of x from the horizontal equation of motion. So now we will start solving the problem. So we are given that v0 is equal to 190 km per hour in the horizontal direction, that is theta 0 is equal to 0. We need to convert it into consistent unit, that is we need to convert the initial velocity into meters per second. Now in a kilometer there are 1000 meters and in an hour there are 3600 seconds. Therefore, in meters per seconds, V0 is equal to 198 into 1000 divided by 3600. And if we calculate it, we will find that it is equal to 55 meters per second. So the initial velocity of the rescue capsule is 55 meters per second in the horizontal direction. The x component of initial velocity v0x is equal to v0 cos theta 0, and since theta 0 is 0, therefore v0x is v0, and similarly v0y is equal to v0 sin theta 0, and this is equal to 0. Now we will solve the vertical equation of motion to obtain the time required by the rescue capsule to land. The vertical equation of motion is y equal to v0 yt minus half gt square, and since v0 y is 0, therefore y is equal to minus half gt square. Now at the point where the rescue capsule lands, it is at a distance of y equal to minus h meters, that is it is equal to y equal to minus 490 meters from the point where it is released. So putting the values of y equal to minus h equal to minus 490 meters in this vertical equation of motion, we get minus h equal to minus 490 meters equal to minus half into 9.8 t square. From this we can obtain the value of t square as t square equal to 2 into 490 divided by 9.8, and if we calculate it, we will find that t square is equal to 100 and t is equal to 10 seconds. So the rescue capsule takes 10 seconds to land at the desired point. Now that we have determined the time taken by the rescue capsule to land, we can use the horizontal equation of motion to find the horizontal distance covered by the rescue capsule. The horizontal distance covered by the rescue capsule is given as x is equal to v0x times t, and since v0x is v0, therefore horizontal distance covered is given by x is equal to v0 into t. Putting the values of v0 and t, we find that x is equal to 55 into 10, and this is equal to 550 meters. Therefore, the rescue capsule covers a horizontal distance of 550 meters before landing. Now we know that tan of phi is equal to x by h. Therefore, using this information to find the angle of line of sight, we calculate phi as tan phi equal to x by h, and therefore putting values of x and h, we find that tan phi is equal to 550 divided by 490, and if we calculate it, we'll find that tan of phi is equal to 1.12. Therefore, phi is equal to tan inverse of 1.12, and if we calculate it, we will find that phi is equal to 48.3 degrees. Therefore, angle of pilot line of sight is equal to 48.3 degrees. This is the required value that we were asked to find in this example problem. So in this video, we have seen an example of horizontally launched projectile. In the next video, we will take an example of a projectile launched at an angle when the initial and final vertical positions of the projectile are not same.